Hi, and welcome back to the History and Philosophy of Science in 6 Easy Steps. This is our Week 3 video. I want to do two things today. One is I want to just briefly review Week 2, the assignments and the readings from Week 2. And then secondly, I want to introduce the assignments for Week 3. Okay, now in Week 2 we looked at Thomas Kuhn's structure of scientific revolutions and the idea of paradigm shifts. And we also watched a video, a play, about the discovery of oxygen. I hope that you saw how these two connected with each other. The idea of the paradigm shift from the phlogiston theory to the oxygen theory of combustion, and the changes that took place through Lavoisier's work. I think the play touched on that fairly well. That wasn't the emphasis of the play. The play, of course, was more about what is a scientific discovery and whether it's a communal thing and what it means to discover something. And I think that's good too. It wasn't totally aligned with Kuhn, but did pick up on some of those. And obviously Kuhn, there's several times in his book where he focuses on Lavoisier and the oxygen theory of combustion and the paradigm shift from phlogiston to that, really to modern chemistry, to a modern view of elements and chemical reactions. That's really when that happened, was in Lavoisier's time. Now, I hope that you got a chance to do those readings in Thomas Kuhn, and I would encourage you to read through that whole book if you have time. I think, and I already saw this in some of your essays, that some of you were impressed or maybe influenced by his arguments. He's got some powerful arguments, the whole concept of a paradigm shift. I want to talk a little bit more about that now. The basic idea, of course, is that we view the world through a set of glasses, right? We view it a certain way because of what we've been taught, because of our preconceived notions, our worldview. And so we tend to look at certain data, we interpret certain data, even though we're not thinking about it as interpreting. It's coming through this filter. And that makes it very hard for us to see other ways of looking at things. And of course, this applies beyond science, right? There's always different perspectives, different ways of looking at things. If we can get to the point where we are open to paradigm shifts, we're open to the fact, even if we just understand, I mean, I think it's helpful to just understand that this takes place so that we can always be kind of on the lookout and aware of ways that we're kind of locked into a certain paradigm and looking for anomalies that might be hints that we're not looking at things in the right way, right? And being open to change in that. I want to focus in on one of his examples, this kind of change of worldview, and that was the example of Dalton, which was later on, I believe, in chapter 10 is when he discussed it. It's a great example of the paradigm shift because one of the things that held people back around the time of Dalton from further understanding or a more modern understanding of chemistry was the fact that people viewed solutions as chemical compounds. So people saw, when they saw salt water, for example, they believed it was a chemical compound. And there were various reasons for that, but it fit in with their affinity theory, with the chemical affinity theory, that salt, for example, had an affinity for water, so it combined with water. And because people viewed salt water as a chemical compound and other solutions, they were unable to accept the idea, or many people anyway, were unable to accept the idea that chemical compounds had fixed proportions of the various elements. And that was a necessary step to developing the atomic theory. Along comes John Dalton. He's a meteorologist. He's not a chemist. He's a meteorologist. So he doesn't have all these preconceived notions. He's not totally locked into the paradigm, the prevailing paradigm of the time. And one thing that he notices in particular, since he's interested in gases, is that you can separate a gas from the liquid that it's dissolved in by simply shaking it up, which is a mechanical operation. And at the time, chemists believed that it was believed that if you could separate something by simple mechanical process, then it was a mixture and not a chemical compound. Now, obviously, you can't do that with salt water. And so you wouldn't see that if you're looking at salt water. But in looking, say, at carbon dioxide dissolved in water, well, what happens when you shake up your soda and open the bottle, right? All the carbon dioxide comes out. You've separated the mixture mechanically. Well, Dalton saw things like this, and so he was open to the idea that solutions were mixtures. Okay, now once you're open to that, you start to see that in solid or crystalline compounds, for example, there are fixed proportions of elements. And so you can kind of see how that led to eventually the whole chemistry community breaking out of that old paradigm, that old way of looking at things, and breaking into the new paradigm of atoms and small whole number ratio combinations of atoms that John Dalton brought about. Now, another question I wanted to raise about this past week is, and Thomas Kuhn's views, is the big question. It's kind of the gnawing question, and he deals with this a lot later in the book. Does science progress? Because when you take his viewpoint, it's kind of like every time there's a scientific revolution, we're not implying any kind of a progress towards some goal or towards some perfect knowledge or perfect understanding, or even necessarily a better understanding of the universe. Instead, it's just a different way of looking at things, just a different perspective. It might be better for solving certain problems, but then again, it might not be as good for solving other problems that the other theory, the older theory, was better at. So, does science progress? One of your classmates brought this up and emphasized it in their essay, their response, and concluded that it does progress because every time, every new theory becomes more logical and more expanded. And I think that's possible, that it is possible that every new paradigm becomes maybe more broadly applicable, or as you said, more consistent, more internally consistent, more consistent with other theories. And so maybe we are progressing. But one thing I want you to consider is this question. What if science doesn't progress? In other words, what if our actual model of the universe just changes and isn't really becoming closer to the truth? But what if the illusion of progress is really because it's technology that's progressing? Because I don't think you can deny that technology is progressing. So technology is getting better. We've solved more and more and more problems. Pretty much everything that humans set their minds to, they're able to accomplish eventually in terms of manipulating the physical world and solving problems. So I don't think you can deny that technology progresses. But we've got to be careful, and we've got to keep this distinction, and we'll talk about this more next week, distinction between technology and science. And they, of course, interact with each other, right? Technological advances often lead to scientific advances because new equipment becomes available, new instruments, more precise instruments, for example, telescopes, balances, electronic analytical balances, that sort of thing. But they are two separate things. And so even though we see massive technological progress and exponential technological progress, it doesn't necessarily imply we've got scientific progress. Now, I'm not trying to say that science doesn't progress. I really haven't answered that for myself. Okay, but I just want to raise the questions, and they're interesting questions. And what are the implications for the future of Kuhn's view? I think this is where it's really cool, because either way, I think he paints a picture that's pretty exciting. All right, on the one hand, if science doesn't progress, then the future at least holds out the promise for new exciting changes, massive changes and paradigm shifts in science. Okay, and then if we allow for the idea that these paradigm shifts are progress, in other words, that they're getting better each time, that each new paradigm is better, is more and more powerful, which really I probably would tend to lean in that direction, then that's even cooler. But I think the most kind of hopeful thing that comes out of this, the most exciting thing, is that it's not this kind of incremental thing where we're just building on little pieces every time, and it's kind of like we've almost pretty much discovered everything. You know, the view you get is that there's lots of room for even massive changes in scientific worldviews, even in the future. I mean, who's to say that the whole atomic theory isn't, that there's not a better paradigm? Who's to say there's not a better paradigm than quantum mechanics or than relativistic physics? Who's to say that? From the Kuhnian view, you really can't say that. There's really no justification for saying that. In fact, you can point out some anomalies. I often think of the whole dark matter controversy. Isn't that kind of a Kuhnian anomaly? Like a problem that doesn't fit current theory, and that no one really has a better alternative yet, and that's the only reason we haven't had a paradigm shift. I don't know. Things to think about. So lots of questions. Maybe Kuhn raises more questions than he answers. I don't know, but it's a pretty cool way of looking at things, in my opinion. And he's been tremendously influential. People use the term paradigm shift in all sorts of fields now. It's not just in science. Okay, let's talk about the next week. Next week we're going to be focusing on another very influential philosopher of science. His name is Karl Popper. Okay, very different from Kuhn, although I think you're going to see some similarities as well as some differences. This is a book that's just a collection of his essays and lectures. It's called Conjectures and Refutations. And that is his definition of science. See, what Popper's doing, he's approaching things from a little different perspective. And what we're going to be looking at in particular here is we're going to be looking at, in particular, his essay called Conjectures and Refutations, in which he lays out his basic definition of science. Okay, now I'm not going to tell you too much about that at this point. What I'm going to tell you is that one of the things, as you'll see, that kind of got him to start asking this question is he was looking at certain fields that claim to be science, like Freudian psychology and the Marxist view of history, for example, that claim to be scientific, and yet they raise some serious questions in his mind. It didn't seem to fit. They didn't seem to fit with the concept of science. And so in this essay that you're going to read, Conjectures and Refutations, Popper lays out his criterion of what we call falsifiability. That in order for something to be scientific, it has to be falsifiable. All right, that's the basic idea. I'm not going to tell you more than that because you're going to read it. And then we're going to have two assignments. In one assignment, you are going to make a post on the forum that I've put under week 3. And your post is going to respond to this prompt. Is economics a science? Because there's lots of economists who claim that it is. And we want to answer the question, is it a science from the perspective of Popper? And of course, you can throw in your own opinions there and your own ideas about what Popper has to say, whether you agree or disagree. And what I want you to do is make an initial post that's your own opinion and your own argument. And then I want you to reply to a classmate's post, okay, on that as well. So that's the first assignment. In the second assignment, I want you to compare Popper with Kuhn in a short essay response. And that you're just going to submit to the Moodle site so that I can grade it. And both of these assignments have rubrics associated with them, as always. Again, look at the introductory videos if you're having trouble finding the rubrics. So that's what we're going to be doing. We're looking now. We're trying to answer the question, what is science? And I want you to be thinking too, as we go through this, of whether technology is science. I'm not going to make an assignment about that, and we'll be touching on this too as we move on further in future weeks. But I'm going to bring it up again in the review in next week's lecture video. Okay, so I hope you enjoyed learning about paradigm shifts, and I think you'll enjoy learning about Popper's views and kind of contrasting them or comparing them with Kuhn's views as well. And I hope you're enjoying this morning. We've got a little bit cooler weather. Storms came through last night. A little bit of break from the heat. Again, if you need to contact me, greenwilliamp@gmail.com or wgreen@eosmith.org, or just message me through Moodle. If you have any questions about your grades, I'm trying to grade things pretty rapidly and give you some feedback. Please just let me know. If you have any suggestions of things you'd like to look into, questions you'd like to ask, again, please let me know and I'll address them in the videos here that I make each week. All right, have a great week and have fun with the philosophy of science.